Welcome to you all in my YouTube channel Experience Mathematics. In today's video, I am going to explain you about curve sketching. It is the topics of class 11. Before starting, I want you to make sure that you please subscribe my channel if you have not already subscribed, so that I will be encouraged to make more videos, and also press bell icon so that you will be informed about my coming videos. So now let's begin today's topic, curve sketching. This one of the beauty of mathematics lies in curve sketching, because different types of equations gives us different type of curve, or some equation gives us a straight line. Okay, so it is visual one, and the beauty lies in this curve sketching. So before starting curve sketching, I want to make some terms clear about this. So this is the topics of class 11 up to class 10. We used to draw curve taking different values of x, and corresponding to the different values of x, we used to make the table and used to write the different values of y, and we used to get the different points, and we used to plot those points in the graph, and we joined points using ruler if the points are in a straight line, and for the curve by freehand we join the points and we sketch the curve. But here, without actually finding out the coordinate of the points, we discuss about the nature of the different types of curve, and without finding out the point, we will find the nature of the curve and we will plot it accordingly. So for this, we need to know some different characteristics of curve. So let's begin. Characteristics of curves. Characteristics of curves. So before we start plotting the curve, we should need to know whether it passes through the origin or not. So this checking whether the curve passes through the origin or not, that also help us to know the characteristics of the curve. Okay, so to find out whether the curve passes through the origin or not, we will substitute x equals to 0 in the given equation. We substitute x equals to 0 in the given equation and see whether y equals to 0 or not. Okay, so if by substituting x equal to 0, y equals to also 0, then the curve passes through the origin. If y equals to 0 for x equals to 0, then the curve passes through the origin. Okay, so if y equals to 0 for x equals to 0, then the curve passes through the origin, otherwise it does not pass through the origin. Okay, here I am writing curve. So according to the nature of the equation, it may be straight line or curve, but for every equations I am writing here a curve. And this is one important characteristics of the curve. Okay, so here example, y equals to x square. Let us see here, when x equals to 0, if you put x equal to 0, y equals to 0, so the curve passes through the origin. Okay, so here x equal to 0, y also 0, so the curve passes through the origin. Okay, so this is one characteristic of the curve. Okay, we need to check before starting to plot. Now next, that is the point on axis, where the curve intersect x-axis and y-axis, that are the point on the axis. So to know this, we see where the curve meets axis of coordinates. For this, to know where the curve meets x-axis, we put y equals to 0 in the equation of the curve. Then we get point on the x-axis where curve meets x-axis. Okay, to know where the curve meets x-axis, we put y equal to 0 in the equation of the curve. Then we get point on the x-axis where curve meets x-axis. Suppose example, suppose there is one curve x square over 4 plus y square over 9 equals to, suppose it is 1. Okay, here if you put y equals to 0, when y equals to 0, then x square over 4 equals to 1. This implies x square equals to 4, and this implies x equals to plus minus 2. Therefore, the curve meets x-axis at 2 0, plus 2 means 2, y also already 0, and minus 2 0. Okay, in this way we found where the curve meets x-axis, or where the curve crosses x-axis. Similarly, to get the point on y-axis where the curve meets, we put x equals to 0. Similarly, to get point on y-axis where curve meets, we put x equals to 0 in the equation of the curve. Okay, so in the same equation, when we put x equals to 0, we get y square over 9 equals to 1. This implies y square equals to 9. This implies y equals to plus minus 3. So the curve meets y-axis at 0, 3 and 0 minus 3. Okay, and the reason behind putting x equals to 0 to get the point on y-axis where curve meets it, on y-axis x coordinate is 0. Okay, in this way we can find out the points where curve meets x-axis and y-axis. This also gives us important idea about the curve. So now next to that is the even function. Even function. Let's define even function. A function f from a to b is said to be an even function if f of minus x equals to fx for all x belongs to a. Okay, so a function f from a to b is said to be an even function if f of minus x equals to fx for all x belongs to a. Example, fx equals to cos x. Here, if you replace this x by minus x, then this x will also be replaced by minus x. This implies f of minus x equals to cos minus theta means cos theta, so it will be cos x, and this cos x is fx. So f of minus x equals to, we have got fx. And another example is fx equals to x square. Here if you replace x by minus x, f of minus x will be minus x square. That will be minus x square means plus x square. This x square again is fx. So here also we have got f of minus x equals to f of x. Okay, so if the curve is algebraic curve and for to be even function, x has only even power. Okay, and this even function is symmetrical about y-axis. Okay, the even function is symmetrical about y-axis. The even function is symmetrical about y-axis. Okay, symmetrical about y-axis means y-axis divides the curve of this function into two equal parts. That's mean by symmetrical matter. And in this type of curve, if x is replaced by minus x, then the function remains unchanged. Okay, so this in this type of curve, if x is replaced by minus x, then the function remains unchanged. At the time, the curve becomes symmetrical about y-axis. Okay, next that is the odd function. Okay, next to that is the odd function. A function a from a to b is said to be odd function if f of minus x equals to minus fx for all x belonging to a. Okay, a function f from a to b is said to be an odd function if f of minus x equal to minus fx for all x belongs to a. Okay, so replacing x by minus x, the function changes its sign. Okay, then it is the odd function. Example of this is fx equals to sin x. Here f of minus x equals to sine of minus x. This will be sine of minus theta is minus sine theta minus sine x, and f of minus x equal to this minus sine x. This minus sine x, which is minus fx we got. So f of minus x equal to minus fx. So it is the odd function. Another example is fx equals to x cube. Here also, if you replace x by minus x, then you will get minus x whole cube. This will be minus x cube, and this minus x cube is minus fx. This implies f of minus x equal to this is minus fx. So this is also the odd function. Okay, and the odd function is symmetrical about the origin. Okay, this odd function is symmetrical about the origin. The odd function, the graph of the odd function is symmetrical about the origin. Symmetrical about the origin means origin divides the curve of this odd function into two equal parts. Okay, so here this fx equal to sin x and fx equal to x cube, these are the odd functions, and this is trigonometric function, and this is the algebraic function. Okay, and next that is the symmetry. So if you need to copy it, then you can pause the video and you can take a screenshot. Now let's move to the next characteristic, that is the symmetry. About symmetry matter, previously also I have explained. The symmetry matter is also is very helpful while sketching the curve. Before this, while explaining about the even function, I have said that if if the curve is algebraic curve, if x has only even power, then it is symmetrical about y-axis, and but if y has only even power, then it will be symmetrical about x-axis. Okay. If in the equation of the curve x has only even power, okay, not odd power, only even power, then the curve is symmetrical about y axis. Okay, so if in the equation of the curve x has only even power, then the curve is symmetrical about y axis. No odd power, only even power. Similarly, if in the equation of the curve y has only even power, then the curve is symmetrical about x axis. Okay, if in the equation of the curve y has only even power, then the curve is symmetrical about x axis. Okay. Example, y equals to x square. Here x has only even power, so it is symmetrical about y axis, because x has only even power, no odd power. Similarly, x equals to y square. Okay, so y has only even power, so it is symmetrical about x axis. Okay, so here only y has only even power, so it is symmetrical about x axis. And if both the power of x and y are even, then it will be symmetrical about both the axes. Another example, x square over a square plus y square over b square equals to 1. Here x and y both has even power, so it is symmetrical about both the axes. Symmetrical about both the axis. Symmetrical about x axis and symmetrical about y axis both. Okay. And next one is symmetric about the original. I have already explained while explaining about the odd function. Okay, if x is changed to minus x, then if there is change in the sign of the function, then that is the odd function, and that will be symmetric about the origin. Odd function is symmetric about the origin. Okay, so that thing I have already explained. I am not repeating here once again. And next there is the increasing function and decreasing function. Okay, so that also will be helpful while plotting. Okay, next that is the increasing function. A function fx, a function fx is said to be an increasing function, increasing in an interval AB if x1 bigger than x2 implies fx1 bigger than fx2 for all x1 x2 belonging to open interval AB. Okay, a function fx is said to be increasing in the interval AB if x1 bigger than x2 implies fx1 bigger than fx2 for all x1 x2 belonging to the open interval. Okay, so here the graph will be like this. Here x1 we can take, here x2 we can take, and the x1 is on the right side, so obviously it is bigger, and the curve, if it is like this, then this fx1 means this height, and fx2 means this height, fx2, this fx1 is bigger than fx1. Okay, this fx1 is bigger than fx2 for x1 bigger than x2, then it is the increasing function. Okay, this y equals to fx is the increasing function. This fx1 is bigger than fx2 for x1 bigger than x2, so it is increasing function. And just opposite is the decreasing function. Decreasing function, a function fx is said to be a function fx is said to be a decreasing function, decreasing in an interval AB if x1 bigger than x2 implies fx1 is lesser than fx2 for all x1 x2 belonging to AB. Okay, so from left to right it is increasing. In decreasing function it will be just opposite, it will be decreasing. So the function will be like this. Here x1 x2, x1 bigger than x2, but this is fx1 and this height is fx2, and this fx1 is smaller than fx2 for all x1 x2 belonging to the open interval AB. Okay, so A can be here, B will be here, and A also. This point is A, and this here outside is B. So between AB, this is the x1 x2 lies. Okay, this x1 x2 are point inside AB, and here also this one point is A, and another point is B. The x1 x2 are the point inside open interval AB. Okay, and these increasing and decreasing functions are also known as monotonic functions. Okay, these increasing and decreasing functions are also known as monotonic function. Increasing and decreasing functions are known as monotonic functions. Okay, and next concept is the periodicity. Periodicity. Okay, so this periodicity is also the very much important concept. Okay, so this will also help us to plot a function fx is called a function fx is called a periodic function with period p if p is the least positive real number such that f x plus p equals to fx for all x in the domain of f. Okay, so periodic means repeating after some certain interval. Okay, so sine graph also periodic in nature, tan also periodic nature, trigonometric functions are periodic nature because after some time same type of graph we will get for this type of functions. Okay, so this p is the least positive real number, means it is the number after that, after this number we will get same nature of the curve. Example, y equals to 10x is periodic function with period pi. Okay, so whether it is periodic or not, let us see according to our definition. Here y equals to fx equals to 10x, so fx plus, let us put pi in here in place of this p, and then here will be 10 x plus in place of x, x plus pi. Here also in place of x plus pi. Tan 180 plus theta, that is tan theta. It lies in third quadrant. In third quadrant, tan and cot is positive, so it will be tan x. That means we have got this tan x means it is fx. Okay, so tan x equals to it is fx. Therefore, f x plus pi equals to fx. Okay, so what we have got, value of p equals to pi. Therefore, p equals to pi. Hence the function y equals to fx equals to tan x. It is the periodic function with period pi. Okay, in this way we can test whether the function is periodic or not. Okay, now next concept is the asymptote. Asymptote. A line x equals to a is said to be an asymptote to the curve y equals to fx if y equals to infinity when x equals to a. That is x close to a makes y close to infinity. That means when one variable has finite value, other variable has value infinity, at the time this x equals to finite value, this equation gives us asymptote. X equals to a becomes asymptote. Similarly, a line y equals to b is said to be an asymptote to the curve y equals to fx if x equals to infinity when y equals to b. That is, y close to b makes x close to infinity. Okay, so for this, just take one example. Let us take y equals to fx equals to 1 over x to be the curve. This implies y equals to 1 over x. Okay, so here when x equals to 0, okay, y will be 1 over 0, that will be infinity. That means y will be infinity when x equals to 0. At that time, when x has some finite value, y value is infinity. At the time this x equal to 0 is the asymptote. Okay, this x equals to 0 is the asymptote. Okay, so x equal to 0 means it is which axis? It is y axis. Okay, this is x equal to 0 means it is y axis. Okay, this x equal to 0 gives us y axis. So y axis will be the asymptote. Similarly, we can also write this equation as x equals to 1 over y. Okay, we can also write this equation as x equals to, because xy equal to 1, and so x equals to 1 over y. And when y equals to 0, x will be 1 over 0 will be infinity. That means x equals to infinity when y equal to 0. When one variable has finite value, other variable's value is infinity, at the time this gives us asymptote. Y equal to 0 is the asymptote, and this y equal to 0 means it is x-axis. Okay, this y equal to 0, it is x-axis, x-axis is the asymptote. So when you plot the graph of this, so its graph will be like this. Yeah, let's see. Okay, so here when x equals to 0, x equal to 0 means it is y-axis, and y equals to 0 means it is x-axis, and this is asymptote means this will x equal to 0, y equals to infinity means y equals to infinity will be up very far here, and y equal to 0, x equal to infinity means also it will be very far here. And now this x equal to 0, y equal to infinity means this curve will touch, this y is only at the infinity means it tries to touch but doesn't touch. Similarly, y equal to 0, x equal to infinity means it touches x-axis only at the infinity means the curve will be like this. It tries to touch x-axis but doesn't touch at the finite distance, it only touches at infinity. It tries to touch very close to y-axis but goes up to infinity. Similarly, when x equals to minus infinity, very far at the end, at the left side, y equals to minus infinity means also it will be very far below this, and when x equals to minus infinity, at the time also y is equals to 0. When y equal to minus infinity, x will also be 0. So this type of curve will also be in this side. Okay, so curve will be of this type. Okay, so this asymptote is also helpful to find out the nature of the curve. Okay, in this way I have explained some basic concepts to plot the curve. Okay, so using the nature of the curve we will be able to plot the curve, and this curve is also represents odd function. Okay, so if you replace x by minus x, then the sign of the function changes. So odd function is, it is symmetrical about the origin. That means this origin divides the curve into two equal parts. Okay, so this part and this part will be of the same shape. Okay, this is also symmetrical about the origin. So I hope that you found this video helpful, and to encourage me to bring similar type of videos in the days to come, you please subscribe my channel right now, and also share these videos with your friends, and I also like you to ask to press bell icon so that you will be informed about my coming videos. Thank you very much.